In this video, we're going to look at how delta G and KEQ are related. For a reaction to be spontaneous, delta G is negative and KEQ is greater than 1. Since both delta G and KEQ are indicators of spontaneity, it makes sense that they must be related to each other. So how are they related to each other? Well, if you're at equilibrium, delta G equals 0, okay, and Q equals KEQ. So we're going to take the equation from the last video and we're going to plug in 0 for delta G and Q for KEQ for Q. So you get 0 is delta G 0 plus RT ln of KEQ, and you rearrange that and you get delta G 0 is minus RT ln of KEQ. So again, R is 8.31 joules per mole Kelvin. Make sure temperature is in Kelvin, and KEQ is your equilibrium constant. So let's try an example. The overall reaction for the rusting of iron by oxygen is given. Using the following data, we're going to calculate the equilibrium constant. So I've given you all the heats of formation and all the entropies. So that same table, just written smaller here. And here's the equation again. So the first thing we're going to do is we're going to find the heat of reaction. Right? So products minus reactants. So 2 times the Fe2O3 minus 4 times iron minus 3 times oxygen, which is 0, gives us negative 1652 kilojoules. For delta S, we're going to do 2 times 90 minus 4 times 27 minus 3 times 205, and that's going to give us minus 543 joules per Kelvin. So keep in mind, one of these is in kilojoules and one of these is in joules. Now we're going to go ahead and plug this into the Gibbs-Helmholtz equation, right? So we've got negative 1652 in kilojoules minus 298. Don't forget to use Kelvin. And then I got to change this to kilojoules. Okay, so negative 0.543 kilojoules per Kelvin. All right, and this is going to equal negative 1490 kilojoules. All right, so now we're going to look and plug into this and see if we can find KEQ. So negative 1490, keep in mind that's kilojoules, minus R. So I'm going to have to turn R into kilojoules. So 8.31 times 10 to the minus 3 times 298 times the ln of KEQ. Okay, so we're going to get the ln of KEQ equals 602, or KEQ equals E to the 602, which if you plug into your calculator probably gives you an error because the number is so ginormous. Okay, it's just a huge number. Usually we can calculate. In this case, I picked an example where we couldn't. Basically, it just tells us we get this ginormous number, and obviously this reaction is very, very favorable. Okay, the bigger the KEQ, obviously. So very favorable reaction. Okay.